Hello, all you beautiful people. Today we're going to be talking about trigonometric ratios. And trigonometry is basically the math of triangles. It means measuring triangles. So what is a trig ratio? A trig ratios are ratios that relate the side lengths of a right triangle, note right triangle, to its acute angles. So here I have a picture of a right triangle. And there's some terms we need to go over as far as the sides. Now, the side that is opposite the right angle, the longest side of the triangle, is always the hypotenuse. So if you want to do these problems by labeling the sides first, that's the first one I would do. Hypotenuse, directly opposite the right angle. Okay? All right, for this example, I'm going to focus on angle N. So everything I'm talking about is going to be in relation to angle N. So what if I wanted the side opposite angle N? So when I look at this triangle, opposite would be directly across from angle N. So that would be this side. And as you can see, if you look at angle N, it's the side of the triangle that's not part of the angle. So the opposite side is the side of the triangle that is not part of that angle, whichever angle we're talking about. And then the third side, which is part of the angle, and it is not the hypotenuse, is the adjacent side. The hypotenuse is the hypotenuse. It's not the opposite, it's not the adjacent. It's the hypotenuse. The side of the triangle that's not part of the angle is the opposite side, and then the other side is the adjacent side. So there's some trig ratios that you need to know. That's basically the lesson. And they are sine, cosine, and tangent. And we use abbreviations for these. And if you look at the calculator, you can find these, see? Sin, cos, tan, that's your sine, cosine, and tangent. Okay? All of these are going to be numbers that are the lengths of the sides of the triangle. So sine is equal to opposite over hypotenuse. So when I look at angle N, opposite, the length of this side, over the length of the hypotenuse. That's the sine of this angle. Cosine is adjacent over hypotenuse. So again, when I look at angle N, adjacent would be this side, so the length of this side, over again the length of the hypotenuse. And then tangent is opposite over adjacent, so the length of the side opposite the angle over the length of the side that is adjacent to that angle. All right? So we're going to do some examples. This is real easy, but first I've got to tell you the magical word that we use to memorize those formulas. And that is Sohcahtoa, okay? Sohcahtoa, sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. Now, there are a lot of different mnemonic devices that people use to memorize the order of these letters. I have one here that I made up, and it says, silly old hermit crab at Hawaii tickled our ankles. There's some about hippies and hogs. You can make one up yourself, but that's just an example. Something important that you need to keep in mind is when you do these, don't forget to reduce the fractions. I mean, you've been doing that since forever, so. Let's do an example. So for the first one, we have this triangle, and it wants us to focus on angle A. So I'm going to come up here and put a little arc mark at angle A. Now I'm going to label the sides of this triangle so it'll make this part easier. So the hypotenuse is the side opposite the right angle. So I know that this 15 is the length of the hypotenuse. All right, and then we want to do opposite. So opposite is going to be the side of the triangle that's not part of the angle. So when I look at angle A, here's angle A, and the side that's not a part is this length of 12. So this is going to be opposite. which means this 9, which is a side of the angle, that length is going to be our adjacent. And now it's just as simple as plugging the numbers in for the formula. So sine is opposite over hypotenuse, the So and Sohcahtoa. So the opposite has a length of 12. The hypotenuse has a length of 15. Then I can reduce that fraction by dividing by 3. And we get 4 over 5. So the sine of angle A is 4/5. Let's look at the next one. They want us to do the cosine of angle A. So here's angle A. Cosine is adjacent over hypotenuse. So adjacent is 9. The hypotenuse is 15. I can divide both those by 3 also. And we get 3/5. So the cosine of angle A is 3/5. Now let's do the tangent of angle A. Tangent is opposite over adjacent. So the opposite is 12 units long. The adjacent is 9 units. I can divide by 3. And we get 4/3. And that's it. Now if I was talking about angle C, these values would be different. But these are the values for angle A. Let's do another example. All right, for number 2, we're focused on angle J. So here's J. I'm going to mark it up. All right, so let's label the parts or the sides. So here's my right angle. So the side opposite or straight across from that will be my hypotenuse. It's the biggest side, right? All right, and then the opposite side is the side that's not a part of this angle. So here's angle J. So the side that's not a part is 20 units long. So this will be my opposite. And then the side that is a part of the angle, and it's the only side that's left, is my adjacent side. And now we're just going to use those same ratios, okay? So for sine, sine is opposite over hypotenuse. Opposite is 20. Hypotenuse is 25. I can divide both those by 5. And I get 4/5. So the sine of angle J is 4/5. All right, let's do the cosine of J. So cosine is adjacent over hypotenuse. So adjacent is 15. Hypotenuse is 25. I can divide by 5. And I get 3/5. All right, and then for tangent, tangent is opposite over adjacent. Again, I can reduce by dividing by 5, and I get 4/3. And that's it for that one. Let's do one more. All right, for number 3, we're focused on angle Z, so I'm gonna mark it up. And now let's label the sides of the triangle. So here's my right angle. The side directly across from that, or the biggest side, is going to be my hypotenuse. All right, here's angle Z. The side of the triangle that's not part of the angle is opposite, so that 5 will be my opposite. And then the side that's left that is a part of that angle is my adjacent. All right, and now we're ready to do our trig ratios. Sine is opposite over hypotenuse. So that will be 5 over 13. And I don't need to reduce. I'm done. 5/13. Boom. Cosine is adjacent over hypotenuse. Adjacent is 12. The hypotenuse is 13. Again, no need to reduce. I am done. All right, and then tangent of angle Z would be opposite over adjacent. Opposite is 5. Adjacent is 12. That cannot be reduced, so I'm done with that trig ratio. And that's it. All right, trig ratios. Just got to remember Sohcahtoa, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Ratios are just fractions, you guys. Reduce and rock on.